All right, hello once again. This is Jeff Scott of Rankin Technical College. I've been going over Farrell's Microsoft Visual Basic 2015 C Sharp an Introduction to Object-Oriented Programming text, and we're on the PowerPoints for Chapter 10 of 14. Chapter 10 it's a continuation of object-oriented speak, and it is, in particular, it is talking about the concept of inheritance. So when you look here, you can see our objectives. We want to learn about inheritance, learn how to extend classes, use the protected access specifier, which I mentioned in the last chapter, override base class members, understand how a derived object is an instance of a base class, learn about the object class, work with base class constructors, create and use abstract classes, create and use interfaces, use extension methods, and recognize inheritance in GUI applications. So, in some ways, inheritance in object-oriented programming is kind of like inheritance with human beings. Now, chances are pretty good, and you can all probably come up with discrepancies in what I'm about to say, but chances are pretty good if husband with big nose and wife with big nose have a child, there's at least a fairly good chance the child will inherit that and probably also have a big nose. Again, it doesn't necessarily have to happen that way, but that's typically what happens. Now, let's just suppose indeed that is what happens. So the child with a big nose, basically when you think about it, has, I don't know, probably I guess two different options. First, they can live with a big nose like their mom and dad do. Or second, they can probably go in to a specialist, to a plastic surgeon or whatever, and get the nose shortened. Okay? But it's not like they can exactly say, you know what, I'd really rather have a nose that looks like this and take off their nose and put on a different one. The reason that I tell you that is that's kind of what you can do with inheritance in object-oriented programming. All right, and that's what we're going to get into in this chapter. Now you notice here they talk about some advantages of inheritance. It saves time, reduces the chance of errors, makes it easier to understand the inherited class, and it makes programs typically easier to write. All right, we've looked at this example before, or an example like this before. This is your typical employee class. You can see that it has two different attributes or data members, an integer, which is ID number, and a double, which is salary. All right, we've got some gets and sets for each one. And we have another method that's called getGreeting, okay? As we get into this and we start talking about it, you can realize that there are several different types of employees. It's possible that a company, as an example, let's say that you've got a company that's a big company that has people who do all sorts of jobs. You could have some employees that were, for example, hourly employees. You know, they work either a set number of hours a week at a certain amount, or maybe not. Or maybe they work 40 hours a week and anything, you know, maybe they make $10 an hour. But maybe any hours they work over 40, they make time and a half, so they'd make 15 hours, as an example. They may also have, as shown right here, maybe commission employees. And maybe they have piecework employees. And maybe they have something else. So what they're showing on the picture here is what's known as a UML, or a Unified Modeling Language diagram. It's a kind of a pictorial representation of what an object looks like. What you do when you work with UML diagrams like this, two things. First, those boxes, the complete box, so this whole thing right here and this whole thing right here, they each represent classes. Okay? And the box gets split into thirds. The top third is the name of the class. The middle third contains all of the attributes data members, whatever you want to call it for the class, and the bottom third contains all of the methods. All right. Also, the other thing that you'll notice is you've got an arrow here that's pointing up, and the arrow is a filled-in arrow. This means inherits. So this means a commission employee is an employee. So by default, what happens is a commission employee can do anything an employee can do, not necessarily the reverse, but a commission employee can do anything an employee can do, and a commission employee also. So they have all these features and functionality, but they also have a commission rate that they can get and set. So if we looked at the examples that were right here, employee is called the base class or parent class. All right. Commission employee can be called the extended class. Sometimes it's called the child class. Sometimes it's called the subclass. It goes by different names. I guess they have their derived class here too. So the parent class is known as a base class or superclass. The child class is known as a derived or an extended class, and it uses an is-a relationship. So again, a commission employee is a or is an employee. As it says, ancestors are a list of parent classes from which child classes are derived. So in other words, let's suppose not only in here do we have this arrow coming up from commission employee, but let's say we've got one over here that comes up and it says hourly employee that also inherits from employee. And then maybe we break hourly employee down to full-time and part-time. All right? So they inherit everything from hourly employee, which inherits everything from employee, etc. What you're doing then is you're building what's referred to as an inheritance hierarchy. All right? And last thing they say on here is inheritance is transitive. So a child inherits all the members of all of its ancestors. Now, that's a little bit of a misstatement or a misnomer. It inherits where it can use everything public. But anything that's private, it doesn't get directly inherited. In order to be able to access these private, would probably be private data members, all right, the commission employee cannot directly, if these were set up as private, then the commission employee cannot directly manipulate those, other than using these public methods. Or if these were made protected, since that's a child, then it can directly relate, manipulate those. So it all depends. Now they're going to show you the syntax for doing this. As it says, you put a single colon between the derived class name and the base class. Again, inheritance works in only one direction. A child inherits from a parent, not the reverse. So here's an example. So notice we've got class commission employee. So commission employee is the child, colon, employee. So this means class commission employee extends or inherits from employee. In Java, you would use the word extends here. In C#, you use a colon. So here's an example. So we create a new employee. So notice it says employee clerk. So that clerk, this clerk right here, this clerk right there, can do everything that's in here. Then we create, after that, a commission employee called salesperson. And they can do everything that's in here. They can manipulate these, but only by using these public methods, and they can do anything that's in here. Again, I think it makes more sense when you start to see some examples. So this is the demo that they have. I'm not saying it's good or bad, but it's their demo. So notice what it says. Any derived class inherits all the data and methods, including private data and methods. So that's not what you said, Jeff. Look at at this first bullet. Look at the second sub-bullet that says the derived class cannot use or modify private data and methods directly. But if it's protected, then they can. Now, this is not really all that recommended. The author says it should be used sparingly because anytime you give, it's kind of like the same kind of reason that most parents don't give their child or their children a lot of responsibility until they've earned it, or typically until they're older. Well, if you make everything protected, what can happen is the parent can lose a lot of authority that it has, and maybe that it should not lose. All right, so here's an example that uses the unprotected. Again, we're going to look at some code with some stuff sort of similar to these in just a bit. And there's the method call. All right. Overriding base class methods. This is similar to what I mentioned to you before. And if you say, what did you mention before? Well, let's look at it this way. Let's say that I create a class called animal. And I say that every animal will have, I don't know, a breed, let's say, I don't know, a name, and the ability to speak. Okay? Well, if I do that, a dog's not going to speak the same way that a cat is not going to speak the same way that a pig is not going to speak the same way as a duck, etc. So the way that we're able to write a speak method, for example, and have it be used by any kind of animal in our animal class is through the use of something that's called polymorphism, as you see on the screen right here. Polymorphism is a Greek term that means many forms. As it says, using the same method to indicate different implementations. Now, the author's example here isn't bad. The author says that although both are musical instruments and both are able to be played, you play a guitar differently than you play a drum. All right? Bicycles and trucks are both vehicles, but they're operated differently. That kind of thing. So the derived class, again, the child class, if it wants to, it can override and hide methods and data from the base class. So it's very similar to what I mentioned to you before, when you get the child with a big nose who's able to kind of take their nose off and replace it with one they'd rather have. Figuratively, of course. Now, there's some verbiage on the screen here to the right that talks about a virtual method. Notice what it says. A virtual method or property is one that can be overridden by a method with the same signature in the child class. So if you want the ability to overwrite something, you have to, when you create it, you have to say public virtual. And then when you actually override it later, you say public override. All right, and that's exactly what they're talking about in here. So in this example, as it says, the credits property is declared with originally it's declared with virtual, and then it's declared with the override modifier, because it has the same header, okay? Public virtual in credits, public override in credits. These have to be the same, and this has to be the same. So as it says, the credits property overrides and hides the one that was defined in the parent. A base class member that is not hidden is visible in the derived class. So they give some examples here. Again, the kind of stuff will only make sense when you start to see it in action. All right? I've already got a few programs that I've created, and we'll take a look at those, but just not right now. All right. Let's suppose that I create, as we looked at, in fact, let's look at the example that we had here before, a while back. Okay? So, when I create a commission employee, that commission employee is going to have their own commission rate. But that commission employee is also going to have an ID number and a salary. Now, if I call the constructor for a commission employee, the only thing by default that it's going to allow me to add is the commission rate. But if I call the base or the parent constructor from the child, I can also set the name and the salary. That's kind of what they're getting to here. You use the keyword base to access the parent method or property. All right? So here's an example. String greeting equals base.getGreeting. So if I want to call this from the parent, in this case, since commission employee is a child of employee, base means the same thing as saying employee.getGreeting. And then there's the way they run it. All right. So as it says, every derived object is a specific instance of both the derived class and the base class. So again, for example, every commission employee is a commission employee and also is an employee. That's what they're saying. You can assign a derived class object to an object of any of its superclass types. As it says, C# will make an implicit conversion from the derived class to the base class. That term is more accurate, and it says the term implicit reference conversion is more accurate because it emphasizes the difference between number conversions and reference objects. So, what do we have here? Well, notice we've got two different employees that we're creating. One is of type employee, one is of type commission employee. The display greeting is part of the employee class, but I can call it and pass either an employee object or one of its derived objects. And you'll notice when we take a look over here, they both work. Now, remember at the beginning when we did this long time ago, we said class employee like this? Well, there's no colon there with something that follows it, so it doesn't extend anything. But technically, that's not true. What we could have written there if we wanted to is we could have written class employee space colon space object, because virtually every class inherits from the object class. The object class is known as the root class. It's at the top. And as mentioned on the last bullet there, or sub-bullet, it says the keyword object is an alias for the system.object class. And you've seen this before. We've used these before. Using system, using static.system.console, which allows us to do read lines and write lines, etc. The object class, again, which is something that every class inherits from directly as a child or indirectly, maybe as a grandchild, a great-grandchild, or whatever. But the object class has 4 built-in methods, and they're shown right here. It has an equals method that will determine whether or not 2 object instances are indeed equal to one another or not. A get hash code, which gets a unique code for each object. A get type, which returns the type or class associated with an object. And the toString, which returns a string representing an object. And quite often that's going to also be overwritten, so you can have it say whatever it is you want it to say. Here are some examples. All right, get type returns a method. So write line SomeWorker.getType. Well, what was SomeWorker defined as? Do we have SomeWorker here? I don't see it. But let's say that SomeWorker was defined as being type, I don't know, type employee. Then that's what would be returned right here. The toString, again, by default, when you use the toString, at least in Java, and I think that C# works the same way. If you just do a get a toString and if you don't override it, you're just going to typically get an address, which represents an address in memory where the object resides. But here, we've overridden the toString method to have it do whatever it is we want it to do, and that's usually the way that it's done. There's an equals method that we talked about earlier that returns true if two objects basically are aliases to one another. So if they have the same memory address, not if they contain the same thing, but do they point to the same address in memory? And that's what they're talking about in here. As it says, when you override the equals method, you also automatically override the get hash code, because the get hash code is going to return a special value that uniquely identifies each object. Instantiating an object of a derived class calls the constructor for the base class and for the derived class. The base class constructor must execute first. So again, when we do this, if we come in here, if we create a commission employee, if we do and we call its constructor, that before that can be called and done, this must be called. So when we write this, what should happen when we create a commission employee, it should first say employee constructed and then commission employee constructed rather. And there it is. And that's the way it works in virtually every type of programming language. All right. When a base constructor requires arguments, you include a constructor for each derived class you create. So in other words, if I have to call the base class and that base class needs something in its constructor, I pass that from right here. And that's what they're saying. All right. Hopefully you remember, because I talked to you, I think it was in the last chapter, about saying that you walk into a bank account, or you walk into a bank and you say, I want to open an account. What's probably the first thing the personal banker, not even personal banker, what's the first thing that the teller will ask you? Maybe it'll be a personal banker, I don't know. They'll probably say, what kind of an account do you want to open? Because to just say I want to open a bank account, that's too generic. You can't open a bank account. You can open a checking account or a savings account or a retirement account, etc. But there is nothing so generic like a bank account. That's like saying you go to a pet store and they say, well, what do you want to buy? Oh, I want to buy an animal. All right. But sometimes you do create something very general and very generic like that so you can create other things underneath it. If you create something that you're never going to make an object of, like a bank account or an animal, that usually is done as what's called an abstract class. So as mentioned there, an abstract class is a class you use to instantiate objects. It's also called a concrete class. I'm sorry. The abstract class is called an abstract class. The classes that you create based off of that. So if I created, for example, dog based off of animal, all right, dog then would be a concrete class. When you create an abstract class, you use the keyword abstract in it somewhere. All right, when you declare an abstract class. Typically, abstract classes contain abstract methods, but it's not required. An abstract method, and you'll see this in just a minute, has no statements, but it must be overridden. So in here's my abstract, a good example. Abstract class animal. So we're saying all animals have a name. All right, and all animals are able to speak. So by saying this method in here, so notice we said the word abstract there, and by saying public abstract string speak, what that means is any class that I create that is a child of animal must incorporate and must have a speak method in it. So dog inherits from animal, and notice how dog has a speak method in it. So dog has got woof, and there's cat, and it's got meow, etc. And you could keep going. When you go and you call the speak method, again, the system knows for Spot to say woof because Spot is a dog. It knows for Puff to say meow because Puff is a cat. That's polymorphism at work. It knows the right method to call based on the type of object that's associated with that method. All right. Again, you cannot have multiple inheritance in C#. With multiple inheritance, what that means is you can have more than one parent for any class. You can't do that. You can do that in the C++ programming language, but not in C#. All right, but if you need to, you can have, as an alternative to multiple inheritance, you can have what are called interfaces. Java supports this also. An interface is a collection of methods used by a class. All right? So here's an example. In an abstract class, not all methods are abstract. In an interface, all methods must be abstract. Everything must be. And it's called interface. Typically, when you name it, you start it with a capital I, as they show right there. So here we've got an interface that we're creating that's called workable. And notice, employee now is going to implement the workable interface. So is animal. All right? So what we're saying is it doesn't matter if you're an employee, an animal, or whatever. If you implement workable, you've got to have a method in there that returns a string that's called work. I do my job. I watch the house. I catch mice, etc. And there's examples. All right. Notice you cannot instantiate objects from abstract classes, so they cannot be instantiated. Nor can you instantiate from an interface. All right. A class can only inherit from one base class. In other words, it can have only in other words, C# supports only single inheritance, not multiple inheritance. But you can implement as many interfaces as you want. So C#, like Java and like a lot of languages, supports single inheritance, but multiple interfaces. So as it says, you create an interface when you want derived classes to override every method in them. And it gives you a way that you can use polymorphism. C# also supports something known as extension methods. What you do with an extension method is you grab something that currently exists. Either somebody else wrote it, or you wrote it, or maybe it's even a system, something, and you add to it. When you write one of these, as it says, it must be stored as a static class. Here's an example, and I'm not going to go through this, but quite often when you're working with hardware, where they call this add check digit, what this is able to do is it helps you make sure that if you've got a lot of data that you're sending over the wire and you have to break it up into what are called packets, that what you sent and what's received are the same thing. That's typically why a check digit would be used. I'm not going to go over that any more than that. All right, you can use inheritance in GUI apps also. Again, they're recapping the benefits of inheritance there. They save development time. They save testing time. The amount of time needed to learn a new feature is reduced, and the base class is not changed. So this was our chapter. My air just kicked in, so I'm very quickly going to say we learned about inheritance. We learned how to extend classes, use the protected access modifier, override base class members. We learned about the is-a or is-an relationship, the object class, base class constructors, abstract classes, interfaces, extension methods, and we ended with talking a little bit about inheritance in GUI apps. All right, when I come back again in Chapter 11, we'll talk about exceptions.